Hello everyone. In this video we're doing activity 7.1 in jamovi. So in this particular example we have a study where people are randomly assigned to one of two groups. One group takes acetaminophen and another group receives a placebo. And then each day while taking these drugs or placebos, they rate how much social pain they've been experiencing. Or in this case, higher numbers indicate greater social pain. So if you look at your data file, you'll notice that it's laid out quite a bit differently than the repeated measures t-test, where for each person gets one row of data in the data file. It's like our very first person here has a pain score of 4. And then we also have to indicate which group they're in. The data is set up so that 1 is equal to the drug group who actually received acetaminophen, and 0 is the placebo group. So our data file just has a bunch of 1s and 0s in it for which group they're in. It makes the output easier to interpret if you change that to drug and placebo. So if you click up here on the drug group, and where it says 0, you can change that to placebo. And where it says 1, we can change that to drug. This isn't absolutely necessary, but it does mean that your data file will, and your output file will be labeled with drug and placebo rather than a bunch of 0s and 1s. Okay. So we're going to do an independent measures t-test by clicking on the t-test menu and clicking on independent samples t-test. Now our grouping variable is which group they were in. This is our independent variable, our grouping variable. And then we're looking at their social pain scores as our dependent variable. Okay. So we're going to need to know the mean difference with confidence intervals, an effect size with confidence intervals, descriptives and descriptive plots, and we're going to be doing a two-tailed test, so we're leaving the hypothesis as two-tailed here. Okay. Next, we're going to ask for a test of homogeneity of variance. So one important assumption of the independent measures t-test is that the two sample standard deviations are both estimating the same population parameter because they're going to be pooled or averaged into one estimate of variability. So what we're looking at here is these two standard deviations. We have a standard deviation of 2.56 and a standard deviation of 1.91. Right? So we can look at those two standard deviations and see that they're not too far apart, right? But we can also look at our homogeneity of variance test to see if that difference we're observing between the standard deviations is likely to be due to sampling error. And so this homogeneity variance test gives us a p-value. So if that p-value is low, and by low we're generally thinking around 0.05, then we're going to be concerned that those two standard deviations aren't estimating the same population parameter. If that's the case, we would need to change the kind of t-test we're doing to a Welch's test rather than a student's t-test. In this case, this p is 0.09, we're not too concerned, especially given that the standard deviations are, one's not like double or triple the other size. Right? So we're going to stick with the Welch's t-test. Right? So we're comparing two means with this t-test, 4.06 and 5.45. Right? So for the drug group, the mean level of social pain was 4.06, and for the placebo group, it's 5.45. You can look at those data graphically in the plots below. So our t-statistic there we computed is negative 2.42 with 60 degrees of freedom, and our p-value is 0.02, which suggests that this difference we're observing is probably not due to sampling error. That's pretty strong evidence against the null hypothesis. The actual difference between the means is negative 1.387. It's negative because the program subtracted drug minus placebo. Had it done placebo minus drug, it would have been a positive mean difference there. The standard error of the difference is 0.57. That's a typical mean difference we would expect if in fact the null is true. And then we have our 95% confidence intervals around the mean difference. So we're 95% sure that the true mean difference is somewhere between negative 2.53 and negative 0.24 in raw score units. If I look at Cohen's d, I have an effect size of negative 0.61, which is a medium to large effect. Okay. Note that we're ignoring the negative sign. Negative doesn't tell us anything about the size of the effect, it just tells us about the direction of the effect. And we know from the means that scores, the social pain scores, were lower in the acetaminophen drug group than in the placebo group. Okay. Now, our 95% confidence interval shows us that we can be 95% sure that the true effect size in the population is somewhere between negative 1.13 and negative 0.09, which is somewhere between nothing and very large. So in this case, again, our sample size is really small, which means that we're getting very wide estimates of these population parameters. If we want more precise estimates, we need to have larger sample sizes to obtain those. But otherwise, that is all you need to know to do activity 7.1.